I said out there I'm Damien. I'm going to talk about energy modelling and engineering for minor dwellings, and particularly this one. I'm a certified passive house consultant and just recently tradesperson. I'm the chapter lead for Finns in Christchurch, and I just want to have affordable houses for people on planet, whānau and whenua. And affordable is not just the price they pay on the day, it's the ongoing running costs and life cycle analysis of the whole building. I have a company which is called the Healthy Home Corporation, engineering happy, healthy homes for people on planet, and just trying to improve, as I said, improve everything. We do energy efficiency advice, energy modelling, geotechnical and structural engineering, and just recently I've also capable of doing blower door testing, just passed the blower door testing exam. And my brother and his wife have a vineyard in Upper Muritori, so there's always wine for happy clients. Is anyone familiar with energy modelling? Other than a few people? Yeah, no? So with the changes to H1 recently, or coming up, where they've dropped, there was 3 ways of calculating. H1 is the energy performance requirements of the building code. So H1 refers to H1 of the building code. And there's a series of performance requirements, and then there's acceptable solutions and verification methods. So when people talk about building code, they're generally talking about acceptable solutions and verification methods, which is, the building code doesn't actually tell you how to do anything in detail. It tells you what they want to, it's a performance standard, what you want to achieve. So when they put out the new standard in 2023, they had a schedule method, which is just a tick box. Pick these things and it'll work everywhere. And that's what people have done. And then there was a few people in $10 Tauranga that said that this thing costs too much, and then Chris Pink tried to reverse it all back. And he was told he's wrong. And so the middle ground is they've dropped the schedule method, and we're going to use a calculation method and modelling method. So modelling is going to be more in vogue. Basically, what modelling does is gives you detailed data-driven decisions. So you'll see this for this house here, you'll see where this house, in terms of its heating demand, performs as a code minimum standard building. So 114 kilowatts, and we're operating down in the 40s and 50s. So we're better than twice a code minimum building. We modelled NZ SIP with different underfloor. So the walls here and the roof here are SIPs. The floor is just timber frame with Terralana insulation, wall insulation underneath it. We tried with foam. Then we tried another brand of SIPs that people will be familiar with, and it doesn't perform anywhere as good because polyurethane that we have in NZ SIPs is much better than polystyrene in terms of its thermal performance. And then what we also did, because obviously at 58 square metres or 51 treated floor area that Passive House uses, we moved the hot water sonder outside. And I'll show you why that's a good idea. Other than that, a square metre of space here is quite an important volume of space. Overheating. This seems to be the thing that everyone's cottoned on to. They don't want things too hot. It frustrates me somewhat because 3 to 4 months of the year we're still too cold and people aren't heating their homes properly, and now we're worried about the 5%, it's about 18 days of the year that we're too hot, which is kind of nonsensical a little bit to me. But anyhow, so the Passive House planning package, which is just a giant Excel spreadsheet, and the engineers in the room will know that this is why it's perfect for engineering, because it's a spreadsheet. It looks at the building as one zone. So it's not the best at doing overheating, because you can have a hot room here and a cold room over there and it balances us out. But it's better than a thumbsuck, or better than most other things for the price of doing the modelling. So you see we're operating at 5, I said, was about 18 days a year of overheating. we move the hot water cylinder outside because the hot water cylinder generates quite a lot of heat, and we drop down to half that. So really, really simple thing to reduce overheating, increase space, stick your hot water cylinder outside. This is a passive house event, so I've got to justify why we're in a house that is not certified as a passive house. Because this is the client, so the particular owner of this house is a young guy that's building up a property portfolio. So he bought this section, demolished the earthquake damaged house, built that one, and he's built this on the back. This is the third minor unit that he's done like that. And we convinced him to do SIPs, and he had a bit of a budget, you know, and so we couldn't get all the things that we would have liked. So final model after we've done the blower door test, which I'll get to, we're down at 55 kilowatt hours. Code is sitting up there 130. By adding thicker panels, I can get down to 40. By adding triple glazing, so we've got double glazing at the moment, by adding triple glazing, I'm in the PHI, Passive House Institute Low Energy Building range. That is a really good standard, and a standard that it should be a basic sort of standard for New Zealanders, especially down in the South Island to get to. It's relatively achievable. So why? Because I was really trying here to get this to Passive House Classic, and I thought I could do it. But this is a balance out of the software for monthly energy balance. And what you can see here, you can see two things. So these are all your losses. So this is all the heat escaping the building. So your biggest losses are out your walls. So hence making the walls thicker in that original model. And then your windows are always a pro and con, because your windows are the weakest part of your thermal envelope, but they also provide the solar gain. And if you have a look over here, that's all pretty balanced, but that's not actually what we want. We want as much solar gain in wintertime as we can possibly get, and we haven't done that. So people were really worried about overheating. We need more sun. We need some bigger windows. To actually get somewhere near Passive House, we need a lot more glass. And even just, it'd make quite a big difference if that door, instead of being black, was glazed. That would make a big difference, because that's north there. Obviously we'll have overheating, but overheating can be addressed with shading. So how do we get to Passive House Classic? It's pretty easy. We just moved the house to Napier. So if I move the whole thing to Napier, without very much, we're already at PHI low energy. We've got a good house, and yeah, easily Passive House Classic. If once it's gone through the certifying process and independent verification, of course. So heating. We need 700 watts to keep this house heated. 700 watts, that's all we need to keep this house heated.
Is it the whole house or just the living room?
The whole house, okay? But as this is going to be rental, we've had to do the Healthy Homes rental assessment, and it comes up with needing 1.5 kilowatts just to heat the space here. So it's overcooking the measurements. So, but we've got a heat pump up there. The smallest heat pump we could find is 3 kilowatts. So that's what's going to go in. But that will also help. That could also help with a bit of cooling in summertime if it's needed. So question time. Passive House is based on a person generating 350 watts. How many people do we need to heat this house?
2.
Just...
Is that the new one? I thought the one I seen was 150 to 200 watts.
No, it's... You need to kind of do the training to see how it works out, but it's based off 350, based off 350 watts. So think about that. What's 700 watts is what? Air fryer or bread machine or pasta maker or something like that, or 2 people. So if people are underheating their houses in terms, especially rental houses, you're putting in an 8 kilowatt heat pump and then people don't turn it on, then what's the point of putting an 8 kilowatt heat pump in? But if you build a house that only needs a kilowatt to heat it, then you can do it with a bar heater or a hairdryer or something. So there's roughly 50 of us in here today. How much heat are we all generating?
1750.
17 kilowatt, 17.5 kilowatt. Yep, it's quite some energy, isn't it?
Take the jacket off now.
So I've actually got a monitor up here and I'm monitoring how much the temperature goes up through the course of this event, just to see.
It's got CO2 on it.
And doing CO2 as well. The ventilation system is running, but I'm not sure it's designed to deal with this many people. So real important part of this whole thing is a blower door test. Builder's worst nightmare the first time they've ever done this, and generally the second and third time. We cheat. We use the WinCon machine from ProClimber. You'll talk to Ben shortly. We stuck it in this window. We spent half a day running around looking for all the leaks, and then we do the final test. There's one really big leak in this house we haven't been able to deal with. Any guess what it is? I've already talked about it actually. Heat pump. 3 cables stuck together. Doesn't matter what we did to tape or foam it, it's still leaked. So yeah, so we ended up with 0.53 air changes an hour. That's a phenomenal effort, considering it's the builder's first time of doing anything. There wasn't a whole lot of help, and they just went ahead. They've never done it before. Passive house, anything below 0.6. Low energy building, anything below 1. Your standard new build house, somewhere between 5 and 7. Your old villa, 20. So you think 20 air changes an hour, that's what? Every 3 minutes, all that air you're heating is just going outside.
2 minutes.
Hitting the planet. 10 minutes, cool. Right, so a key part of passive house is the 5 passive house principles. You'll probably hear about this over and over again. In New Zealand, they generally say, when people talk about that, it's which principle they're leaving out, which you can't do. A building's a system, you've got to do all of it. Plus the energy modelling you saw either. So how have we done on this house? We've got Martin's windows. We've got Marcus's MVHR. We've got Louis' building skills and Ben's tape. We've got James's SIP. And we've got Warren and my design. Any passive house people know what that is. It's a weird joke. No errors, everything's shiny. So that's the modelling. Let's just go back to the engineering. There's a few structural engineers around, so we'll do that too. So TC3, red zone's just across the road, as you probably saw when you came in. Ground's appalling. We've used the MBIE Type 1 surface structure. It's a standard design. It's one that I wasn't that keen on using because its performance is not as good as some of the others. We had to play with it and adjust it slightly because of the softer ground conditions and because we're in a flood zone. So what that looked like is we had got 1200 ply, so we used a full sheet of ply. We had to build the ground up to do that. We've got our ventilation area under there, and because we have to have ventilation, we have to bring the ground up, and that was the detail for doing that. I am now a bit of a convert. So this is the piles going in. Obviously doing testing to get 200 kPa at the bottom of the hole at 600 deep. That was all tested fine. The piles going in ready for concrete. This is the ply skirt going on. The house is still quite wobbly until these 2 braces went in underneath, and then it was a lot more rigid. And then once the ply's gone on, it's really, really, really sturdy. That foundation is really sturdy, and I'm now a bit of a fan of this system. So it's pretty easy to do. And yeah, then getting ready for the SIPs. So the floor's down, all the internal walls are up, and this was the first corner. SIPS always starts on one corner. You get that first corner plumbed and square, and you have no problems after that. I was going to help. We were going to have an event, but that didn't work out. I was going to help the builders on this first corner, but I was doing my Passive House Tradies course at the time with a couple of other people that are in the room here. So they just did it. I called in, had a look, and they didn't have any problems putting together, and you'll hear from Louis about that shortly.